Since this is the third code walkthrough that we are doing, we don't need
Yeah.
more introductions anymore. So the stage is all yours.
Okay, sure, sure. So yeah, I'll start with a quick intro about myself. So hey folks, I'm Anirudh, an SD at Kalvium, and today I'll be on behalf of Compilerd, a service that I am actively working on and maintaining at Kalvium. So mostly I'm here to speak about it and set some context that is needed for FOSS Hack 2024. So yeah, I think the agenda is mostly clear, but yeah, I'll quickly go through it once again. So in the next 1 hour or so, I'll walk through Compilerd and we'll mainly talk about what is Compilerd, what is the vision that we are having behind it, and then we'll have a walkthrough of the code base with the small local setup and which will just make it easy for folks to uh, make some contributions in Compilerd. So yeah, with this I will start. Hope so. I'm audible, right?
Yes, yes.
Yeah, yeah, totally.
Sure, sure. So yeah, what is Compilerd? So primarily, it's an online code judge for evaluating code submissions password. So yeah, this is one small line of Compilerd. But yeah, mostly what will happen is you will input a language, you will input a code or a script along with that language, and if there is an input that is optional, and it will return you the output of the code. Mostly I'll also demo this towards the end in the section where we do a local setup of the project. So initially it was meant to do all this, that is executing code against a given language and against a given input. But recently we have extended it with a couple of more functionalities evaluating subjective questions, where we leverage AI to evaluate a subjective problem. We construct prompts and make API calls to OpenAI to get a score for a subjective type of question. Apart from this, we also added a feature that allows evaluating of front-end web development problems. So what will happen in this is a student can write code for a front-end web development problem, which is evaluated in an automated way against the test cases in the test file. This is one thing. One last thing that we have added is evaluating DB assignments. So what happens in this is, again, a user is expected to write a set of queries against a given database schema and a given problem statement, and then Compilerd is responsible for evaluating if those queries uh, give the exact same output as expected in the assignment or in the problem statement. So yeah, mostly it's around if you consider all these things, it is around evaluating a simple single file assignment, as in let's say Python, C++, C, what all the system supports as of now, or multi-file assignments, that is let's say front end or development assignment, DB assignments, and one more I mentioned, that is subjective assignments, where what we do is we make simple OpenAI calls and we respond with the score against a given solution. Um, yeah. So this is a small intro about Compilerd. So yeah, any questions? So Ria, since we don't seem to have any participants, so how do we go about questions? So we just skim through it, or yeah,
I
how do we
So
go about
if I have anything that I feel is relevant to what participants might encounter, then I'll ask something. I think so far your explanation has been clear, so no worries about that.
Sure, sure. Okay, makes sense. Yeah. So speaking about the vision that we have compiled ID. So yeah. So so we have other solutions also like Jet Zero, which are addressing the same problem. But what is the need for compiled in that scenario? So the simple answer is all the platforms that are existing like Jet Zero, they often fall short in terms of cost effectiveness due to the setup requirements and continuous server operations, which can be quite expensive. So the sole idea behind Compilerd is to create a solution that is both cost effective and scalable, we opted for a serverless architecture to ensure we are only charged for the requests the system serves, and at the same time maximizing efficiency and minimizing the cost. So yeah, this is like the if I in one line we wanted it to be cheap. So that is the vision that we have behind Compilerd and how it's written. Couple of more details that I would like to share over here. So while this was being set up, we had some initial considerations. We considered AWS Lambda, but it also aligns considering the serverless architecture. However, at that point of time, we felt a couple of significant downsides that kept us away. One was the home time that AWS Lambda takes. The cold starts can have latency, though it is okay at the scale which we are currently in. But yeah, again, for a real-time execution platform, it is something that matters. Also, when we were starting on Compilerd, Lambda did not support containers, which kind of restricts you with what all you can do with Lambda. So all these things or all these points made Lambda less appealing, despite its otherwise robust features. Coming to Google Cloud Run, which we are currently using. So what the case with Cloud Run is, it offers best of both the worlds. That is, it combines the on-demand nature of serverless platform along with the reliability of traditional servers. How? So like it keeps one container running by default all the time, which ensures minimal latency for initial requests and excellent scalability for subsequent demands. Also, Cloud Run's flexibility to deploy containers with custom environments was a game changer for us at Kalvium. Basically, it allows us to pass a container with any environment that we can set inside it. This capability significantly broadened the range of languages, the frameworks we could support, which made Cloud Run the perfect fit for our needs. Also, with any serverless architecture, scalability is by default. So this thing is already handled by Cloud Run. We get it as part of the setup. One main couple of more points that I would like to share over here is now since the platform the compiler is responsible for executing code of users, custom solution of users. Security is something that needs to be taken care of in this case, and for that we have multiple checks or multiple practices in place that we have in Compilerd. So one of them is file system sandboxing. We restrict writes or writable operations to only /temp, and even we start the main process under a different user and a user group which has restricted permissions. So we kind of uh, uh, sandbox writes, so which restricts any harmful activity a user might try to do with his code, with his or her code. Also, we also do network sandboxing. So in this case, what happens is now since we are allowing users code to be executed in our environment, so we want to prevent any abuse that might initiate from our servers. So for that, we enforce firewall rules by using IP tables available in Linux. And yeah, by default, we block any outbound traffic to and prevent any kind of abuse originating that could originate from our servers. So this is one thing. Apart from that, also we have also set memory limits and time limits for every code execution that comes in Compilerd. By default, we are having a generic timeout of 10 seconds currently for every request, and memory limit is set as per the container memory limits that we have for our environments. So yeah, that is configurable. But yeah, we do run every submission under given memory and time constraint. This is also one security practice that we follow in Compilerd. We also with this we also have couple of issues specifically tagged with FOSS Hack around TLE and MLE, which I will go through towards the end of this
Uh,
discussion
Sorry, about what?
about time limit and memory limit.
Time limit. Yeah, yeah, got it.
Yeah, so I'll be mentioning them towards the end when we discuss about the other issue. Yeah, so with this, I think vision is over. Extra details that I wanted to share are over. The description of Compilerd I have given. Now I would like to move ahead with setup requirements and local setup that I can demo and yeah, which can be helpful for anyone who is contributing.
Yeah, yeah, thanks.
So I would just share and please let me know if you folks can see my screen. I'll share in a second.
Yeah, I can see it now.
Sure, thanks. Also, I'll be looking up in my screen, so please don't mind. Yeah, so as part of requirements, initial requirements, I'll just pull up the README itself. That prerequisites. The prerequisites are mentioned over here also, but yeah, I'll also walk through them quickly. So what we need is we need Git, we need a Node.js environment, we need Docker, any API client we need, such as Postman, and we also need an ID to set up and run this locally. I'll quickly do a local setup and run. Like, is the font readable or should I increase the?
It's readable right now, but maybe in the recording it won't be. So zoom in might help. Yeah,
Does
thanks.
this look fine?
Yeah, that's much better.
Sure. So yeah, I'll just check out. So for users or for contributors contributing, I'll follow exact same steps mentioned in the README so that they can also follow same set of steps. So we have cloned the repo and we have opened the ID at the given at the path where we downloaded the repo. We are inside the directory currently and we'll do a dependency installation now. Let me pull up the terminal. Install. Yes, this might take some time. Yeah, so the installation is complete. Now we need to build a Docker image. So we can run this directly without a Docker environment, but the problem is we will need to manually go and set up the environments for running different languages. Let's say CPP, Python, everyone might not have all the setup. So we have a Docker file and we can directly get the setup as part of that. So I'll quickly do a Docker build over here. We'll be running this command, Docker build. I already have that present as part of my history. We are doing a Docker build -t demo. Hmm. So we have a built image now. Now we'll run a Docker container with the built image using this command. Again, I have it in my history. I'll just use that Docker run. So yeah, this is the port flag. This is one extra env. We can pass a dummy value over here. Basically, this is required for the AI evaluation, that is, which leverages the open API key. For now, we'll just pass a dummy value and we'll use the image name over here and we'll run the container. Yeah, so we have the server running. Quickly, I can uh, run a dummy request. Yeah, so this is a request on localhost slash API slash execute, which is the endpoint. And the body over here is two parameters, two keys. One is language. We are passing Node.js and one is script. Simple Node.js script. So yeah, this is the output. You can try changing this. Yes, you can see the output over here. You can try Python also once. Simple scripts. Yeah, you can see over here. So similarly, we can like once we have the container running, we can make requests using a client. So I think this is complete local setup that one needs to have to be able to run this and make contributions to it. Yeah. So with this, we complete our local setup and setup requirement step also. Now I will move ahead with the code base walkthrough. I'll point out important parts of code base, one has to, which one will mostly be uh, mm, using and interacting with. So yeah, so mostly over here, sec. Yeah. Hmm. So we have a single endpoint over here called slash execute. It's a very simple application. No complications over here. We have a single slash execute. We make a post call to it and we'll see what happens. So this is the controller, which is just responsible for validating any request that comes, executing for the data that is validated and over here, and then transforming the response and then responding. If we go inside is valid for execute, we'll see a schema over here that we expect. So if I need to link this to the request that I just made on Postman, so that it's easy and relatable. So for the code path where we are executing a code with a language, like let's say where we are executing a Python code or where we are executing Node.js code, what we need is a language and what we need is a script. Similarly, depending on the other code flows, let's say we are having a request for AI evaluation or we are having a request for DB type of assignments. The schema is set accordingly and the validations will happen accordingly over here. It's a joy-based validation, and I think it's quite readable and understandable. Based on the parameters, we can figure out what keys are required for requesting a given use case. So yeah.
What happens when like an unsupported language is passed? Because I saw just like string validation there.
So I guess currently it's only a string-based. Like there is no check for any existing languages over here.
Yeah, maybe we
So
could
yeah.
make that an issue or something.
Yes. We can make that we can make that as an issue. Yeah. So this is the validation part. Now we move into the execution part. That is the service layer over here. So over here, we are first forming a response object with the set of keys like output, execute time, status code memory, all those things that we require. And we have four flows that gets distributed from here. One is for AI evaluation, one is for front-end web development evaluation, one is for DB type of assignments, and the other one is for execute code. So let's go through this initially because we just sent a request and tested this out. Over here again, broadly what is happening is, yeah, couple of initializations over here has input files from the request object, and again script language input if we have any. And then what we are doing over here is we are getting the language config based on what language we got as an input. So if we have a quick look at the language config, what we have over here is for every supported language we have set of keys, compile, run, timeout, file name, memory, which define the, let's say compile defines the compile command that needs to be run. The command for running the solution, we have a timeout, we have a file name. This is mostly the output, or this is the name of file that will need to be used when we write the file on the disk. And this is the memory that we need to allow, or the memory constraint that we need to have for that given language. So now, okay, like at this moment of time, this is generic. This is same for every given language. So yeah, there we have an issue on this itself where we want to make this configurable. So yeah, we have the language config. Then we also have a run script method over here. We'll be using this multiple times. What this method does is, um, it does an exec on the command that we have that is passed as a parameter. So basically, we are running a command line process over here using exec as part of run script method, and it does some memory checks in a set interval. But yeah, mostly we can consider run script to be doing a exec on the command being passed to it. So yes, I'll go back. Yeah. So we are doing a cleanup over here. Let's say any temporary files from the previous request that might have been written on the disk. We are doing a cleanup of that. Then over here we are writing the code that we have received as part of the request to the under temp with the file name from the language config that I just showed. Now we are building a compile command over here, which is we cd into temp and then we use the compile command over here. This compile command we pass to run script, again responsible for running command line commands, and we get the compile log over here. Basis on compile log, we prepare a compile message, and there's a condition over here which checks for if there is no compilation error over here. This is the flow. What this does is, again, it will form a command over here. This command is responsible for running the output now. So will build this command. So for language Java, we have certain condition, and apart from that, we have certain condition over here. What we are doing over here is, again, we are seeding into temp, and we are using ulimit, and we are using timeout, and then we are using the run command over here. So essentially, what we are doing over here is we are forming a string of command where we want to execute the run command under timeout and under ulimit. That is under memory and under time constraints. Basis on if we have any input available, we write the input under temp at input txt, and when we update our command accordingly over here. Now again we call the run script method with the command. This will be responsible for executing the code. And yes, Amok.
So, like, is there a problem with Java having memory limits or something that you removed it for that?
Actually, like, I don't have complete context of this, but yeah, I can get back on this. This
All
was
right, sure, sure.
the Yeah. There might have been some issues due to which we decided to separate this apart, which
All
is
right,
different
got
from other setup. Yeah. So yeah, now we have executed the code and we have the output log. Now we set the output in the response object basis on the conditions. Like if we have any error message, we'll prepare error message, or we will just use the std out and we will append or we will add that to the output over here response. Uh, if we had any compile error over here, we set the error to 1. And over here also, if we face any issues, we set the response.error equal to 1 and we return from here. If we go back, we return the response over here. So in the controller, yeah, we transform basis on the object that we have got. We transform the output execute time, like adding all the fields that are required over here, and then we use the respond method over here. Yes. Hmm. So, hmm. So this is a helper method over here which is responsible for responding based on what output we have received from the service after it has been transformed. Any doubts up till here?
No, it's been quite clear.
Okay. So yeah, this was a very basic walkthrough of the execute code path that we have for executing languages with the code against them. We have other flows also. Like, should I give a quick walkthrough for that also?
Sure, but one thing I wanted to ask before, like, what's the AI feature that you mentioned? I don't think I remember reading that in the README. Not, maybe I missed it.
Huh. Yeah. So basically, what the AI feature over here is, so this Compilerd, as I mentioned in my previous introduction also some time back. Now, initially it was meant for only executing code against a given language, but eventually we extended the functionality to support several other features also, like doing a subjective evaluation. What is subjective evaluation? Uh, any kind of, like how we write subjective questions, right? Any paragraph based submissions, so which AI can evaluate. So we don't do much over here. We just prepare a prompt and we make API calls to OpenAI. With the proper prompt, we set the question, that this is the question, this is the answer, and this is the rubric. Uh, Evaluate this answer against this question as per the rubric set, and OpenAI respond to the score. So
Good,
this
good.
is
Yeah.
this is basically an API call to OpenAI with the proper prompt that we create over here, and then we respond back. So
Yeah.
this basically allows us to evaluate any subjective kind of problems. Yeah. So I'll give a quick walkthrough of the other code flows also over here. So this is the get AI score. Get AI score. One sec. Yes. Get AI score over here. Hmm. So if you see over here, we are creating or constructing a prompt over here with the question that is being passed to this, the rubric again passed, and with the user answer. And on a broad sense, what we are doing over here is with the prompt, we are calling the execute prompt method. Over here, we are using the OpenAI SDK to make a call with all the fields. That is a message, role. This is a system prompt. This is a user prompt. Model we are using. Again, this is coming from the config that I just showed you. Over here, below we have a model over here. And yeah, it's a bunch of stuff going on over here. So what we do over here is we make an OpenAI call over here, and then we are expecting the response to be in a certain format because we have seen AI hallucinate. What we need is we define in the response or in the prompt that we need the output to be a JSON object with a score available. But yeah, certain times we have felt that or we have realized that AI hallucinates. So we have validation over here. So mainly, mainly what is happening over here is we are making an open API call over here, and then we are validating over here if the response from OpenAI follows the schema or not, and basis on that we return. Let me know if I am too fast or if it is too difficult to follow from the.
Yeah, no, I'm getting everything. No worries.
Okay, sure. So basically, what is happening over here is there is a retry mechanism happening over here. I think it's like pretty straightforward to understand if someone goes through it. But the generic idea what is happening over here is we are making couple of calls to OpenAI and we are calculating some confidence over here. So what confidence mean is we do some calculation with which we realize that is let's say is there a lot of deviation that is deviation in the score that OpenAI is responding in. So let's say we want the score to be out of 10 and for a given user answer we are getting 9 in one call and we are getting 4 in another call. Okay, so we calculate the confidence over here, and once we are sure that there is a confidence that we have achieved in the calls, or let's say we have exhausted the number of calls that we can make to OpenAI for a given request to Compilerd, we respond out, or we come out of the flow. So yeah, bunch of retry mechanism happening over here. Execute prompt. Nothing apart from that. We are just retrying in. Um, what do I say? Like we do 3 retries, we do 7 retries, things like that, and then when we find that we have valid requests exceeding a given amount, we come out.
Makes sense. Yeah.
Yeah. So yeah, only the retry mechanism over here, nothing apart from that, and multiple calls to execute prompt, which I just showed you above.
Yep. Yep.
Yes. So this is the ultimate check that we have over here, where we make sure that we are not making excessive number of calls to Compilerd, or let's say we are not getting confidence and we are making 20, 30, 40, 50 calls. So we have a fallback mechanism over here and we come out. So yeah,
Yep.
pretty straightforward over here. The other flow I can quickly show you. Execute SQLite 3 query over here. Yeah, so this is again, we'll get a bunch of queries and we'll also get a URL to a DB file
Yeah.
that SQLite supports.
Hmm.
And broadly, what we'll do over here is we will write the file. One sec. Download SQLite database. Yep. So we download the file, uh, database file, and we write it under the path present over here. It is present in app config. Yep, temp database.db, and we call execute. So yeah, this is bunch of checks over here. We're checking for if path or if directory exists or not exists, and then we are downloading the file to a given path. Over here, what we do is we execute SQL queries. So we are initializing DB over here. Yeah, so over here we are using SQLite 3 Node.js module, which is responsible for interacting with the database file.
Yep.
So we start the DB over here. We have queries. Uh, um, yeah, one sec. Awesome. Yeah, some not very much sure what is happening over here, but yeah, I can get back on this.
So essentially,
Hmm.
when you say you evaluate, let's say an SQL task, like how does the flow look like for someone being evaluated?
Yeah, so the flow is simple. We download the file, write it
Hmm.
to temp database.db. We
Yeah.
initialize a DB using the SQLite module over here.
Yeah.
We parse the SQL statements that we've received as part of
Uh,
the API request to Compilerd, and one by one we execute the statements over here
Good. So,
against.
if how does the evaluation happen? Is it like you tell it, I want my database in like a particular state, and that is the um, and you evaluate if it is in that state, or is it something else?
No, so acha, I got your point. So
Yeah.
Compilerd is not responsible for. Sorry if I use the wrong word, but Compilerd is not responsible for evaluation. Compilerd is only responsible for stateless execution of API calls. It will
Got
just
it. Got it.
respond the output to the SQL queries that we have passed to it against the
Okay. Okay.
DB file. And
Got it. So
other
you
services, yeah,
so you pass it an init file, and it'll execute it and give you the output file.
yes. It is
Got
nowhere
you. Got it.
responsible for evaluating or
Evaluation.
checking if the output is fine or not. That other
Understood.
services which we'll call it is are responsible for doing that stuff.
Understood. Yeah. Okay.
So
Thanks for
yeah,
clarifying.
this is yeah, the same stuff, simple stuff over here. We parse the queries and then we make call, and then as per the output that we're getting from DB, we'll just respond back, and the services interacting with Compilerd can check if the output is as per expected or not, and then it can be evaluated. This is the DB flow, and the last flow is execute multi-file over here. Hmm. So yes, so I'll just give some context on this. So what we'll get is quickly I can show you the input format over here. Uh, one second. Hmm. Yes. So what we need over here is a URL. What this URL will contain is this URL will contain an object which will have keys and values. Keys correspond to file path, and values correspond to content that has to be written in the files at the given path, if I'm making some sense. Um,
So this is for projects which have multiple files that you need to run.
right. So, like, did I make sense in the input format? Or
Uh, uh, so a bit confusing. So you have keys and values, and keys are the name of the file, and values is
so keys is not file names, keys
sorry,
is
yeah,
file path.
file path.
File
Got it.
path from root where the file will be written.
Yeah. Got it.
Okay, and the content will again be a string for the content of the file. Like once you
Okay.
write,
Understood.
once you create the file on disk, you have to write that content in that file. So the
Got
idea
it.
over here is again I can like go into details, but yeah, idea over here is we get a URL, we download the JSON, and we iterate through all the keys. We create files, write the corresponding content in the files, right? And then do our evaluation. So I'll just quickly walk through over here. So we do a pre-cleanup over here. So okay, I'll do one thing. I'll come to this after I go to the flow. Otherwise, it is confusing over here. So what we are using is we are using Jasmine as the testing environment. I'm not sure if you have heard of Jasmine, but yeah, we are supporting two type of setups. Uh, One is a simple HTML, CSS, JavaScript setup for front end, and one is a React setup for front end. So this is an integrity check that is happening over here. We can, I think, ignore this for now. It is just a check that we make before executing a submission. Now, if you see over here, we have two flows. One is for static setup that I just told you, and one is for the React setup. I can walk through one of them, and the other one is kind of similar itself. So what we do is over here, we start a static server. Huh. So prior, yeah. So I missed this part. Yeah. So basically, we are doing a get submission data from GCS. It is nothing but making a get call to get the file,
Yeah.
and we write files to disk in this method. Again, simple step to get the files, right? Now, when we come in the if condition for static setup, what we are doing is we are starting a static server over here. So this is responsible for
Serving the
starting
file.
serving the files at the path where we have written the files that we have extracted through the
Yeah.
JSON, right? Yeah, again, like we can go into details, but yeah, this is what this method is doing on an abstract, on like on a very high
And then
level.
you'll run Jasmine on this server.
Right. Jasmine files are already present. So what we have is we have Jasmine file and we have students code written as part of the file. So when
Yeah.
we dump the files on disk, we have Jasmine code also and we have students code also in the same setup. Now as soon as we let's say over here I do a run test and I do a puppeteer.launch. I launch a headless browser over here, right? And I try to I initialize a new page and I try to go to the localhost and I try to serve. I try to make a request to the static server, right?
Yeah.
So as soon as the DOM is loaded, instantaneously the Jasmine scripts are run.
Yeah.
And what happens is now since Jasmine setup, what it does is it populates the DOM with the test cases.
Yep.
And what we are doing is we are kind of scraping the DOM to get which test
The
cases have
evaluation
passed
results.
and which have
Okay.
failed.
Got it. Got it.
So yes, this is what is happening over here. I am going to the page. I am waiting. So yeah, a bunch of automation stuff happening over here. I am waiting for this thing to be painted on the DOM. Finished. Otherwise, I know that there is a problem if this thing is not finished because there is some issue and the DOM is not getting populated. Now, yeah, this is custom implementation over here. We are waiting for a couple of elements in the DOM, that is Jasmine summary, and then we query all the elements, we iterate on them, and we extract passed and failed test cases over here, insert them into array, okay, push them into array, and return the results from here. So again, in this setup also, Compilerd is only responsible for writing files to disk, starting server, starting puppeteer, headless browser, making calls, extracting values from DOM and responding.
Yeah.
And other services calling Compilerd are responsible for
The test
the
cases.
validation. Yeah, whether we have what all test cases have passed and what all is the score.
Makes sense. Yeah.
So this is, I think, this is a very broad walkthrough that I'm doing. But yeah, should I go into more details? I'm not
I
sure.
don't think so. I think learning that is a part of the hack, so that
Yep, yep,
student should figure that out.
sure. So I think these are the four branches that we have in this. Um, yeah, and only one endpoint, and we respond. Yeah, nothing apart from this happening over here. Yes.
Yeah, I think that makes total sense.
So yeah, this is the walkthrough part. Let me quickly move ahead with the other. So yeah, key points that needs to be taken care of in this is one is like as I think you would have got an idea, like it is stateless. So every request is served independent of what happened in previous request. Its whole purpose is to work on one request and respond and just forget about everything. So it is stateless. One, this is one thing. And like in this, so I like if anyone who is contributing over here, like might end up making several calls in the container, and it might end up misbehaving
Right.
because in GCR when we run it, we have a container level setting that we have set over here. That is, we allow only one request per container, and GCR spins up another container if one container is already occupied with a request. So
Right.
one thing that contributors might need to make sure over here is like when they contribute, they don't make multiple concurrent requests on the container. This is one thing. Otherwise, they might see some misbehavior. Um, yeah, so this is the I think that this is the only main point that needs to be taken care of while contributing. There is no other key point apart from this.
I think you
The
mentioned earlier about some time limits and memory limits, right? So, uh, what were you going to mention about that?
Okay, yeah. So time limit, memory limit is as part of checks that we have. So when this execute code is like when we go into this flow, when we have a request for executing a code for a specific language, we by default are running the command or the user solution under
Okay, okay. I thought there might have been something like to keep in mind while contributing.
no, that is not something that is to be
Yeah,
kept in mind.
alright, no worries. Because I
So
think I remember like seeing an issue or a pull request some time ago that ended up increasing the time or memory limit because it was not working for them. So maybe, yeah.
which issue, like if you could point out,
Uh,
I can
yeah,
give you
I'll
some
just
context.
take a look. You can go ahead while I'm searching by the way.
Okay, sure. So I guess the only part that is left now is discussing on the issues that have been tagged specifically for
Um,
FOSS Hack.
sorry, Anirudh. Did we mention about the tests also? Or did I miss that out?
Test cases.
Yeah.
Yep. So yeah, so we have existing tests over here, but yep, these test cases are around the execute code flow itself. That is, I can quickly show you over here. We have bunch of test cases. I think we have two per language. For CPP, we have two. For Node.js, we have two. For Python, we have two. Yeah, so we have test cases, and obviously, like we can even target like more test cases over here, or like yeah, once someone is contributing, this can also be a point where they can validate their contribution if it's working or not. Fine.
Okay.
But yeah, I think we welcome some test cases if possible in other flows. But yeah, As of now, test cases are available only for the execute code flow.
Okay.
And yeah, if the requirements for running test cases is nothing. We just need to have the server running. I guess it's already running over here. And what we need is we just need a command to run the 1 second npm run test. Mm, yes. Hmm. Yep. So this is how we run test cases over here. We see CPU and all of passed. OpenAI tests have failed because the key that I mentioned when I started the container was a dummy key over here. If you could see this one, those have failed. But yeah, apart from that, the other test cases have passed. So yeah, it's just a npm run test to validate if the contribution is working or not, at least
Okay.
for the execute code flow.
Cool. Okay.
Yes.
Amog has shared the issue link in the chat.
1 second.
I think essentially the issue was that the Go runtime was crashing because it did not like the 512 MB U limit placed on it. So maybe we could uh, tell participants that you should find a way to respect the memory limits that the project sets and not increase them or anything.
Anirudh, I think you're on mute.
Oh, sorry. I don't know
No
how it happened.
worries.
Yeah. Yeah. So yeah, I remember this issue. I think for the same exact reason, we had updated the README and we added extra env over here to set
Nice.
the allowed RAM over here. So I guess for Golang, 1 second, web service, language config. Yes, I think for the exact same reason,
Right,
we
right.
had added Harsh had added this env over here because yeah, for him 512 was not working. So yes, I think this thing also we can take care when we are contributing. But yeah, for now at least he has added the env. Let's say if someone wants to add support for another language also, we can extend this functionality over here to support the use case.
Makes sense.
Hmm. But yeah, if someone wants to try and so locally, I don't think it will be an issue. Yeah, it will be an issue because we are running under the memory constraints. Yeah, so we can try passing this CNV. I think it is already mentioned as part of the README over here.
Right, right.
Hyphen he allowed RAM. We can pass this, and at least for Go, this should work. For other languages, it is not an issue. We don't even need this flag over here.
Nice.
DNV
Okay.
variable. Yeah, nice, good point. Amol, thanks. I think we can go to the issues now if there is nothing else.
Yeah.
Yeah, let's do that.
And I just
Yeah,
wanted
so
to
we.
mention something. I've been going through the issues a little bit myself. I think the first issue, right? Front end
Mhm.
to run code, is that already being worked upon? I feel that someone had actually tried working on that issue in a PR.
I yeah, so I guess that's so I think folks have opened this repo. So I think they are hiring and they have opened this repo with a task with all these issues. I guess someone is trying to contribute, but yeah, I think team is not working on this.
Okay.
I I'm not sure like if that is an issue. Like I don't understand the concern. Like, can you please help me?
No,
Because I'll accordingly
no.
speak to the team and.
Sorry, what I meant was, that issue that
Mhm.
was being marked up, right? The first issue, there
Mhm.
seemed to be already a PR on that. So, are you still open for like more PRs, or do you want some improvement on that?
So yeah, I'll just clarify. So those PRs that we have over here over there are present as part of a task which
Okay,
was
okay,
given to for a hiring task. I don't think we will be accommodating those PRs, or else if we'll be accommodating, we'll close this issue. Otherwise, I think there are a bunch of PRs, but they are not in a state where I can go and merge them.
okay.
I think that is
Understandable.
only a working Yeah, that is only a working solution that those folks have tried out. Yeah, in any case, if we are accepting any solutions from those PRs, we'll close it. Otherwise, like, yeah, I don't think they're in a state to be merged. There is a bunch of, I guess, uh, clutter over here. I'll ask the team to like clear this if that activity is over. This is one thing I'll take care of.
Okay. Thank you, Anirudh. I think we can discuss a few issues if we could.
Yeah, yeah, I'll quickly go through them. So yeah, the first one is add a simple front end to run code against any supported language. Hmm. I think it is self-explanatory. So by this issue, what we intend is, so like how I showed, how I used Postman to make requests to Compilerd initially when I was demoing. So what we want with this issue is a simple front end. Uh, like by this we can have a client and interacting with the Compilerd makes it easy with this issue. So this is what is intended. I'll need help from you both in like if I am if you need more like if contributors might need more context and if the context that I'm giving is less. So yeah, please I'll go through, but yeah, please tell me if I am not giving enough context.
Yeah, sure. I think the first issue that seems, self-explanatory, and yeah,
Mhm.
I don't, I have understood that part also. Amok, do you have any comments on that?
Oh, so sorry, I was muted. I was speaking. I understood. No worries about the
Yeah.
first issue at least.
Okay. So yeah, for the add PG support, this is like already we have a solution that is supporting SQLite. I think this will be a kind of similar activity to what we have in SQLite support. But yeah, this is also what we expect. Support for PGLite. So yeah, I already have demoed the flow for SQLite, how we are doing it, and I think similar is what is expected. Like just context for the contributors who might be watching this video. Apart from that, add support for memory consumed per request, add support for time taken per request, MLE and TLE. So with TLE and MLE, what we expect is we expect a request level uh, constraints for time and memory that we are seeking over here. So currently, what we are having is we are having generic constraints for memory and time for each request. But with these four issues, what we intend is we intend a request level memory limit exceeded and time limit exceeded support. And for these two issues, I guess this will be like these will be auto handled when we try to implement this. This is my assumption. Because when we try to add support for time limit per request, we'll anyways end up calculating the time taken per request. So yeah, but the main idea behind these four issues is to have a request level constraints and not have a generic constraints that we currently have in the repo.
Yeah, totally
Um,
makes sense.
Apart from that, yeah, add Golang support is one sec. Okay, it was closed. Yeah, yeah. So yeah, I think any number of uh, language support we add is Go itself. So yeah, this is as part of other language support that we have. This is also there where we intend a request coming for Golang to be executed in Compilerd. So yeah, I guess we have gone through the issues. So let me know if you folks have any question.
So these issues make sense. Maybe we could add that language list validator issue, or I could add it.
Yep. Sure. No, no, I'll add it.
All right. Right.
Hmm. I like
Okay.
going forward. I think we have some time. We eventually I'll see if I can add more issues over here so that it can give a more variety of issues to the contributors to work upon.
Awesome. Awesome. Yeah.
Yeah.